Hello everyone, today let's just do one more integer partitions question. It's going to be Quantipos number 68 just to get a little bit more practice with these. So we know what p sub k of n is, we've been working with that a lot, so let's just fill in the values for p sub k of n for all integers going for k from 1 to 7 and for n from 0 to 7. So we're just filling in this table where these are going to be our k values, these are going to be our n values, and basically, like for instance, this right here would be p sub 1 of 0, this one right here would be p sub 1 of 1, this would be p sub 2 of 0, you get the idea. So let's start off and just think about some stuff. Okay, what's the number of ways to distribute 0 items into one group? And that's actually one of the initial conditions given to us right here, and it makes sense that it's 1 because if we have one group, well, how many ways can we partition 0 into it? Well, just one way, right? We can just give 0. Same with like two groups, how many ways can we partition 0 into them? Well, we have to give both of them 0. There's only one way, right? It doesn't matter how many groups we have, there's only one way to partition 0. And that just basically tells us that the whole first column of our table is going to be 1s, so let's fill that in here. And another pretty easy one to think about is just going to be this top row here, right? If I have one item and I'm distributing it into one box, well, there's only one way to do that. Same with two items, obviously. Same with three items. For one box, there's going to be ones across the board as well. So now let's think about this one right here. What's the number of ways to distribute one item into two boxes? Well, let's draw our two boxes over here. I have one item. The only thing I can do is just give 1 and 0. So this is going to be 1 right here. Now let's think about this one, the number of ways to distribute one item into 3 boxes. So imagine I have 3 boxes. Well, you can just see that it's also going to be 1. It doesn't matter how many extra boxes I add. I only have one item, so there's only one way to partition it. So actually for this column here, it's also all going to be 1s. Now let's think about this one, the number of ways to distribute 2 items into 2 boxes. So I have 2 boxes here. I could either have 2, 0 or 1, 1. So just by doing that, we know that this is going to be 2. Or we also just could have used this recurrence relation, which we talked about in the last video, where this term right here was going to be the number of ways such that no box is empty. So it would be this one here. And this is going to be the number of ways such that a box must be empty. So it would be this one. And if you watched the last video, you know that this holds true only when n is greater than or equal to k. And when n is less than k, we actually have this relation, p sub k of n equals p sub k minus 1 of n. And why exactly is that? Well, let's look at this situation, right, where we're distributing 2 items to 3 different groups. And this falls under this category. N is going to be less than k. So what it's saying is that p sub 3 of 2, which is going to be here, is equal to p sub 2 of 2. It's just going to be equal to 2. Similarly, for this p sub 4 of 2, it's going to be equal to p sub 3 of 2, which was also 2. So these are all going to be 2s down the board. And the intuitive reason for that is just because no matter how many boxes that we add on, like when we increase our k value, we're just adding boxes. It doesn't matter because there's still only 2 ways to partition 2, and it's just into 2, 0 or 1, 1. So now let's move on to solve right here, where we're partitioning 3 objects into 2 boxes. Now n is going to be greater than k, right? 3 is greater than 2, so we can use this relation right here. So all we have to do is take p sub k minus 1 of n, and that's just going to be the number directly above the one that we're trying to solve for, right? We're trying to solve for right here, so it's going to be up here. Now to find this term on our table like this, we just take n minus k in the same k row. So our k is 2, we're going to be looking in this row, and then we're going to take n minus k, where our n was 3 here, and we're going to get 1, so we're going to take this value. And let's just add them up. We're going to get 2 when we add 1 plus 1, obviously. Now let's solve for right here where we have 3 and 3. Again, n is equal to k, so we're going to be using this one here. Okay, how do I do it? I just take the one above the one we're trying to solve for. Then I take 3 minus 3. It's going to give me 0, so I'm going to look right here, and I'm going to add these up, and then I'm going to get 3, right? And now at this point in the column, k becomes greater than n, so we can just repeat all the way down. These are all going to be 3s. So now you can kind of fully see the pattern that we are doing, so I'm going to get rid of this and just fill in the rest of the table. Okay, for right here, I take the one above it. I take 4 minus 2, which is going to give me 2, so I add these 2 up, so I get 3. Boom, now I solve for right here. I take the one above it. I take 4 minus 3, I get 1. I look in my same row, and I add these 2 up now, so I get 4 here. Now we solve for right here. N is equal to k, right? So we still use the same relation. We have boom, and 4 minus 4 is 0, so we take this one, so we're going to get a 5 here. Now n becomes less than k, so we know that we just fill in 5s all the way down. Now I'm going to solve for right here. I take this one and I take 5 minus 2, which is 3. So I take this one, so I get a 3 here. Now I'm going to solve for here. 5 and a 3. Again, I take 3. I add 5 minus 3, I get 2. I get 5 here. So basically, if you notice the pattern, I'm kind of going down in a diagonal like this, right? The next one, I'm going to take 1 and add it to the one above. So I get 6. Now I'm going to take 1 and add it to there. So I get 7. Now I'm equal, so I just repeat all the way down. Okay, for right here, I take the one above, and then I find 6 minus 2. That's going to give me 4, so I go down to that same row, and I get 3, so I'm going to get a 4 here when I add them up. Now I'm going to go down in the diagonal, right? So 4 plus 3 is going to give me 7. 7 plus 2 is going to give me 9. 9 plus 1 is going to give me 10. 10 plus 1 is going to give me 11, and then we have to repeat. Now let's just do this last row. Let's speed run it. 3 plus 1 is 4. 4 plus 4 is 8. 8 plus 3 is 11. 11 plus 2 is 13. 13 plus 1 is 14. And 14 plus 1 is 15. And this concludes our table, which is just going to be the final answer. I'm sorry if that was a little bit tedious, but I just think it's a good question just to get the full grasp of what's going on with integer partitions. And that's pretty much all there is to it.